Hi students, this is Alex here. In this video, we are going to find the half-range Fourier sine series for the given function f of x is equal to 4x minus x square in 0 less than x less than 4. So expansion formula is f of x equal to summation n equal to 1 to infinity bn sine n pi x by L, but here L is 4 because they have given 0 less than x less than 4. Now to find bn, we use integration 2 by L integral 0 to L f of x into sine n pi x by L. Now we are going to replace L, that is 4. So 2 by 4 integral 0 to 4 f of x is 4x minus x square into sine n pi x by 4 dx. Now we can cancel these two. So this is 1 by 2. Now we are going to apply Bernoulli's formula to integrate this. So 4x minus x square we have as a first term, which we can take it as u, and we have sine n pi x by 4 dx. Now u equal to 4x minus x square, v equal to sine n pi x by 4. Now u dash will be 4 minus 2x. Then u double dash will be minus 2 and u triple dash will be 0. Here this integration is minus cos n pi x by 4 whole divided by n pi by 4. Then v2 will be minus sine n pi x by 4 by n pi by 4 whole square. Then v3 will be cos n pi x by 4 by n pi by 4 whole cube. Now applying this in the formula, we have bn equal to 1 by 2 uv1 minus u dash v2 plus u double dash v3 minus u triple dash v4 dot dot dot, and we have limit from 0 to 4. Now u, which is 4x minus x square. So 1 by 2 4x minus x square into v1 will be minus cos n pi by 4. So minus cos n pi by 4 x by n pi by 4. So we substituted u v1, then minus u dash v2. U dash is 4 minus 2x. So minus 4 minus 2x into v2 is minus sine n pi by 4. So we can make this as plus sine n pi by 4 by n pi by 4 whole square. Then plus u double dash, which is minus 2. So minus 2 into v3 cos n pi by 4 cos n pi by 4 x by n pi by 4 whole cube. So even there is a x term here. Then after that we are going to apply the limit, which is 0 to 4. Now using the upper limit 4, this will become 16 minus 16, which is 0. So this is 1 by 2 0. When using the upper limit 4 here, we get sine n pi, that is also 0. And the last term will be minus 2 into, when I put 4 here, we get cos n pi. Cos n pi is minus 1 whole power n by n pi by 4 whole cube. Then minus, when I put the lower limit 0, both are 0, so it is 0. Because of sine, this is 0. And we have only last term, which is minus 2. Cos 0 is 1 by n pi by 4 whole cube. Now we have this as equal to 1 by 2 minus 2 into minus 1 whole power n by n cube pi cube by 4 cube, which is 64. Then this will become plus 2 by n cube pi cube by 64. Now we can take the common terms out. Minus 2 is common in the numerator and denominator we can take n cube pi cube by 64. That 64 we can take it to the numerator, and this will become minus 1 whole power n, and when minus 2 is taken common from this, the remaining will be minus 1. So now Bn we get minus 128 by n cube pi cube minus 1 whole power n minus 1. If n is odd like 1, 3, 5 dot dot dot, minus 1 whole power 3 minus 1, this will become minus 1 minus 1, so we get minus 2. If n is even like 2, 4, 6 dot dot dot, minus 1 whole power n minus 1 will become, in place of this, if I take a even number 2, this will become 1. So 1 minus 1, that will become 0. So totally we have Bn as minus 128 into 2 by, actually it is minus 2 by n cube pi cube, and we also have a 1 by 2 outside. This we have to keep writing it. So here 1 by 2 is there. So even here 1 by 2 is there. So I keep this 2. So we can cancel these 2. So this Bn will be when this is n is odd, and it is 0 if n is even. So finally Bn equal to minus into minus plus. So we can take 128 by n cube pi cube when n is odd, and this will be 0 when n is even. So we got the value of Bn. This we are going to substitute in the expansion formula, that is f of x equal to summation n is equal to 1 to infinity Bn, which is 128 by n cube pi cube into sine n pi x by 4. But this in place of 1 we have to use odd, because we have from odd to infinity. So we can take the constants outside, that is 128 by pi cube is taken outside. Now summation n is equal to odd till infinity, we have 1 by n cube into sine n pi x by 4. This is our f of x. We can take n as 2n minus 1. So this is 128 by pi cube. Now summation becomes from n equal to 1 to infinity, and this is 2n minus 1 whole cube, and we have sine of 2n minus 1 into pi x by 4. This is our f of x. This is the required Fourier series expansion, half range series, half range sine series for the given function f of x. For proving the second part of the question, in the second part we have deduce 1 by 1 cube minus 1 by 3 cube plus 1 by 5 cube dot dot dot. So we have to take a value for x. For that, instead of the last terms, we are going to use this. It is easier because when n is odd, we have this. So let's take x as 2. When x is 2, we get f of 2 equal to 128 by pi cube summation n equal to odd till infinity 1 by n cube sine n pi into 2 by 4. So we get n pi by 2. Now we are going to expand this. F of 2, f of x already we know the function is 4x minus x square. So when it is f of 2, it is 4 2s are 8 minus 2 square, which is 4. So totally this is 4. So 4 equal to 128 by pi cube, and we are going to expand this. I am going to put odd values for all the n. So 1 by 1 cube into sine pi by 2. Then plus 1 by next odd is 3. So 3 cube into sine 3 pi by 2. Then plus 1 by 5 cube into sine 5 pi by 2. So like this it keeps going. Now we can take this pi cube here and 128 to the other side. So 4 pi cube by 128 will be sine pi by 2 is 1. So this is 1 by 1 cube. But sine 3 pi by 2 is minus 1. So minus 1 by 3 cube. Sine 5 by 2 is plus 1. So 1 by 5 cube. The next will be minus. So like this our series keep going. After cancelling this is 32. So finally we are getting 1 by 1 cube minus 1 by 3 cube plus 1 by 5 cube dot 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 will be pi cube by 32. So the term which they ask us to deduce we got here. Let's check with the question. 1 by 1 cube minus 1 by 3 cube plus 1 by 5 cube dot 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 is pi cube by 32. So we got it here.